The first part of this project was to connect all the hardware together. I connected the LCD and keypad like so to the TV microcontroller. Port A is connected to the enable and RS select pins of the LCD. Port B is connected to the data bus lines for communication in 4-bit mode. Port D is connected to the keypad columns, and port E is connected to the keypad rows. I connected everything like so using jumper wires. This calculator can perform a number of different functions, including addition, subtraction, decimal points, powers, brackets, multiplication, division, and scientific notation. These functions can be accessed by pressing the relevant buttons. The delete button deletes a single character. Press the shift button before it, the delete button deletes the entire line. If you accidentally press the shift button, like on most calculators, you can cancel the shift by pressing it again. For example, if I want to type 3 to the power of 3, I press 3, then shift, then 3 again, printing a power. If then accidentally I press the shift again, I can press it a second time to cancel and thus be able to press the 3. If you perform a basic sum such as 1 plus 1, pressing equals will cause the calculator to compute your input and display it on the next line. To enter a new sum, simply press any button on the calculator and it will clear the display and allow you to start again. I've come up with a series of tests to prove the correct functionality of my calculator. To test addition, 2 plus 5 equals 7, 1 plus 5 equals 6, and 43 plus 251 equals 294. Test subtraction, 7 minus 3 equals 4, 2,847 minus 234 equals 2,613, and 799 minus 945 equals negative 146. To test multiplication, 5 times 5 equals 25, and negative 5 times 25 equals minus 125. To test division, 250 divided by 10 equals 25, minus 23 divided by 2 equals minus 11.5, and minus 34 divided by 56 equals 0.6071. To demonstrate decimal points, 10.135 plus 2.2132 equals 12.3482. Minus 10.32 minus 10.45 equals minus 20.77. And 12.34 times 3.14 equals 38.7476. I can also carry out scientific notation. 10 times 10 to the 2 is 1000, and 1 times 10 to the 3 times 2.1 times 10 to the 3 is 2.1 million, and then finally minus 1 times 10 to the 3 is minus 1000. So far I've demonstrated that all the required operations that were set out in the brief have been fulfilled independently. I've also implemented BIDMAS into my calculator, so the operations will be carried out in the correct order as demonstrated by 2.14 times 3.57 plus 12 minus 54 is negative 34.3602. As an extra feature, I implemented brackets, a quick demonstration of which would be 1 plus, open bracket, 2 minus 57.3, close bracket, times 12 divided by 2, which is minus 330.8, with a different result if the brackets were not present. Finally, to test some n cases, I've done the following sums involving 0. 0 plus 0 equals 0, 0 minus 0 equals 0, 0 times 0 equals 0, 0 divided by 0 equals 0, and 12 divided by 0 equals 0. The LCD contrast can be adjusted by rotating the potentiometer located next to the keypad, like so. To make the calculator easier to use and understand, I created some labels for the buttons that show their functions in the center and their shift functions in the right-hand corners. For this project, I designed a custom case for my calculator. I designed this in Fusion 360 and then printed it on my 3D printer in blue PLA.